In this lesson, we're going to continue working with graphing, but these are going to be linear inequalities in two variables. So we are going to be using the coordinate plane, but these are going to be inequalities as opposed to equations. You may want to take a minute to pause this video and write down the steps for solving inequalities. For solving using graphing these inequalities. These particular steps use the slope-intercept method, the y equals mx plus b method for graphing. So let me give you a little bit of an overview and then we'll talk more about the steps. Suppose you have an equation, y equals, let's say, 2x minus 1. We know that if you're thinking about it as y equals mx plus b, that you will begin at -1 on the y-axis, and your slope, or your moving instructions, 2/1. That means up to right 1. All right, if I were to graph this line, beginning at -1, going up 2 blocks, going right 1 block, it is difficult in this particular setting to use a straight edge. I'm going to try, but no, I'm just going to do a freehand line. Please understand that on a piece of graph paper, you would actually use a straight edge to do that. Now, every point on that line, y is equal to twice the x minus 1. When we are above this line, and all of these points are above the line because the y values are up. So if I talked about all of this, in this region, y is greater than 2x minus 1 because it is above the line. If instead I talk about all of these points that are below the line, then the y is less than 2x minus 1. So the line which is drawn, which is the graph of an equation, is the boundary line. Those points above it is where y is greater than that. The points below it, that's where y is less than the line. So remember, above, that way, below, that way. When we graph inequalities, let's take a look at these steps. The first thing I'm going to encourage you to do is write the inequality in the form y greater than or equal to mx plus b, and the symbol will vary by the problem. Sometimes it'll be a less than, a greater than, less than or equal to. It'll be one of the 4 inequality symbols. I encourage you to go ahead and use the y-intercept and the slope to graph just the boundary line. Then, if the line, if equal is part of the symbol, then you will use a solid line because the line itself is part of the solution. If it is strictly a less than or strictly a greater than, then you want to indicate that the line is a boundary but not included. You will dot the line. You'll see this in examples in just a minute. If the symbol is a less than or equal to, you shade below the line, like I did here. If it is greater than or equal to, you will shade above it. Then a little discussion about vertical lines because there is no such thing as above or below a vertical line. So if you were asked to graph x is less than 2, all right, the line x is equal to 2 cuts through the x-axis at 2. I'm using a dotted line because it doesn't say equal. Less than. X is less than as you go to the left. So the graph of this one would be on this left-hand side. That's what the graph would look like. So for a vertical line, if the symbol is a less than or equal to, shade to the left. If the symbol is greater than or equal to, we would have shaded to the right. If it had been either of these including with the equal, this line would have been solid. All right, those are some things to think about. Let's look at more of this with the example problems. All right, this is what it will look like in MATLAB. It says graph the following inequality. Well, I'm going to take 4x plus 2y is greater than negative 8, and I'm going to isolate the y. So subtract 4x, and I have 2y is greater than negative 4x minus 8. Divide everything by 2, and I have y is greater than negative 2x minus 4. At this moment, go ahead and make some decisions based on the inequality symbol. Because it does not have equal, this will be a dotted boundary line, so dotted line. Because it is greater than, you will shade above. So I make those decisions as soon as I get y is greater than or less than or whatever the symbol may be. All right, looking at this inequality, I know that the b value is negative 4. That means I will begin at negative 4 on the y-axis. The slope is negative 2. If I put that over 1, it says to go down 1 and right 2. If you're doing this in MATLAB, you will click the line graph tool. It will be a lot clearer than what I'm doing. You can click to enlarge it if you need a bigger graph. I will begin at negative 4 on the y-axis. From there, I will go down 2 and right 1. As soon as you click on that second point, you're going to get a graph. Now, if you wanted a dotted line, you will click this one. Otherwise, if you want a solid line, you will click above. And you can change it if you have forgotten to get it correct. All right, so mine is a dotted line. Please forgive the fact that this will not be perfectly straight because it's difficult to use a straight edge with this technology. But there is my dotted boundary line. Dotted because equal was not part of it. Shade above because it says the solution are all the y's that are bigger than this. So I will pick one of my shading colors, and above this is everything up here. Now I'm doing this with my pen. How would you do it? You would determine which side to shade, then you would click on the bucket tool, click into this region, and all you have to do is click anywhere on this side of the line, and this will all get painted with a color. Then you'll ask it to check it. Now, what this means is, and this is a little different than what the author of the book would say, every point on this side, this point, this point, this point, this point, this point, all the points, if you were to take the x and the y coordinates and put them into the original statement, all of these on the shaded side would make true statements. All the points on the non-shaded side are not solutions. They would make false statements. I'm not requiring you to do the check because we're just using the symbol itself to tell us which side to shade. Let's look at number 2. All right, I have 3x plus 5y is greater than 15. I choose to do this as slope-intercept. So I'm going to subtract 3x from both sides. I have 5y is greater than negative 3x plus 15. Divide by 5. And I have y is greater than negative 3/5 x plus 3. The symbol, what does it tell you? Well, it does not have equal. That means it's going to be a dotted line, just a boundary. It also says, because it says greater than, you will shade above. The b value of the boundary line is 3, so I'll begin at 3 on the y-axis. The slope, I choose to put the negative with the top, and that will tell me to go down 3, right 5. So begin at 3. There we go. And remember, I'm using the line drawing tool right now, and I want a dotted line. So I began at 3, then I go down 3, right 5. That'll give me another point. Sorry. A dotted line will form between those. Please forgive my crooked line. And then I will tap on the bucket. I know that I want to shade above, so I will tap on this side. What will happen will be that this side will all become shaded. Every point on this side is a solution, whereas every point on the other side is not a solution. All right, let's look at number 3. Oops. All right, I have x minus 5y is greater than or equal to negative 10. Once again, I want it with y by itself. So subtract x. I have negative 5y is greater than or equal to negative x minus 10. Divide every term on both sides by negative 5. Now, I don't know that you remember this from your previous study of inequalities, but when you divide both sides of an inequality by a negative, then the inequality symbol reverses. That's when it reverses, is when you either multiply or divide by a negative. You probably will not have an occasion to multiply, but if the coefficient of y is negative, then you will divide by negative, the symbol will reverse. So I have now y is less than or equal to, I'm going to call the slope, it's negative 1 over negative 5, negative over negative is positive. 1/5 x, negative over negative is positive 2. All right, what does this symbol tell me? Well, because it has equal, it will be a solid boundary line. The points on the line will be included as solution points. It says less than, so we will shade below. If you did not reverse the symbol, you'll shade the wrong side. All right, I need to now notice that the y-intercept is 2, y-axis. The slope is positive 1/5, which means up 1, right 5. So there's a 2, then up 1, right 5. Get another point there. Now, in MATLAB, you will have used the line tool. This time you will have clicked solid, and this line will be just a very slightly inclined line. Once again, I keep trying to emphasize that my lines are not perfectly straight. I wish they were, but the tools I'm using don't provide for that. I'm supposed to shade below this. I will click on the bucket, and then I will click on this side of the bucket. So what will happen will be this side of the line will all get shaded. And this time, every point on this side is a solution, as well as every point along the line. All of those are solutions, which means their x and y coordinates make the inequality true. Let's look at number 4. I have x plus y is less than or equal to negative 4. Subtract x from both sides. Y is less than or equal to negative x minus 4. The inequality symbol, what does it tell me? Because it has equal, I will use a solid line when I graph it. Because it has less than, I will shade below. Where will that boundary line be? Well, the y-intercept is at negative 4 on the y-axis. The slope, all right, it's right here. There's an implied negative 1, and it's over an implied 1. Negative 1 over 1, which means down 1, right 1. So I will click the line tool. I have a solid line and I begin at -4. From there I go down 1, right 1. I get a line which is solid that looks like this. I would then click on the bucket and I'm going to shade below it. So simply tap on this side, anywhere on this side of the line, and this side will become shaded. So every point on this side, every point on the line, all of them make that inequality true. Okay, we have a couple more. I have 6x plus y is greater than -6. Subtract 6x from both sides. That gives me y is greater than -6x minus 6. The inequality symbol is right there. Because there's no equal with it, I know it will be a dotted line. And it's a greater than, so I will shade above. I will begin at -6 on the y-axis. My slope is -6/1, which means down 6, right 1. I think this may be a problem, and I'll talk about that as we begin to graph. All right, line tool, dotted line. I begin at -6 on the y-axis. If I try to use these instructions and go down 6 and over 1, I'll be off the grid. The point does exist, but I'll be off the grid. So I need to keep the 6 and the 1, but switch the signs and let the 1 be negative. This tells me instead to go up 6, left 1. So instead of going down and over, which would put me over here somewhere, I'm going to go up 6, left 1, and it puts me here instead. You can see that it's the same line, but I can actually put that one on the grid. You can always change the signs. All right, this was a dotted line. It's a very steep dotted line. I'm supposed to shade above it. Sometimes people have trouble telling what is above a very steep line. Just get on the line and move up. That means that I'm on this side. Anywhere over here with your bucket, you will click and you will get this entire region to be shaded. That means that every point on this side is a solution. The points on the line are not. Points on the line do not make it true. That's why it's a dotted line. All right, I believe we have one more. We have x plus 4y is less than or equal to -8. Subtract x, so I have 4y is less than or equal to -x minus 8. Divide everything by 4, and I have y is less than or equal to, I'm going to call this -1/4 x minus 2. All right, so what does this symbol tell me? It tells me that I will have a solid line, and because it's less than, I will shade below. Whoops. I will begin at -2 on the y-axis, and my slope is -1/4, which is down 1, right 4. All right, line and solid because it has equal. I will begin at -2. From there, I'm going to go down 1, right 4. I'll get another point. The line will show up in Math Lab. Sorry, not a perfect line. And I will shade below it, which means that I click on the bucket. I click below the line, this side will get shaded, and it will look a little bit like this. Okay. One last thing, there aren't any problems, but I'd like to mention to you that if you were asked to graph y is greater than 2, y is equal to 2 cuts through the y-axis at 2. Because it doesn't have equal, it would be a dotted horizontal line. Because it says greater than, you would shade above. All right, there wasn't one of those in the exercises, but I wanted to mention it. If you had x is greater than 2, the line x equals 2 is a vertical line because it doesn't have equals. I used a dotted, but with x, I can't say above and below. I say left is less, right is greater. So greater than 2 is on this side, and it would look more like this. Okay, so just in case you encounter one of those special kinds of inequalities. Remember that early in the video, you had access to these rules that would be helpful to type. All right, good luck with those.